Okay, so here we have another exercise called loyalty bonus, part of the conditional statement section. This will be the final video in this section. So hopefully we get through these remaining exercises in this video. If not, we'll drop one more video, but I think we'll be able to get through them in this one video. So this one's called loyalty bonus, and I don't know why it's doing this. I think for some of these exercises that I've seen so far, some of them are already counting. I don't know why. But maybe it's just a glitch on my end because earlier when I logged in on the other exercise in the previous video that we did yesterday, I had to redo them because for whatever reason the points didn't count. So anyway, we're told that this program calculates the end of the year bonus a customer receives on their loyalty card. The bonus is calculated with the following formula. If there are less than 100 points on the card, the bonus is 10%. In any other case, the bonus is 15%. The program should work like this. So we're asked how many points are on your card. We say 55. It says your bonus is 10%, and you now have 60.5 points. But then we're told that there's a problem with the program and that with some inputs, it doesn't quite work right. So we're asked how many points are on your card. We write 95. Then it calculates the 10% bonus. And then it calculates the 15% bonus and says that we now have 120.175 points. So it says, please fix the program so that there's always either a 10% or a 15% bonus, but never both. So let's run this and see what it's doing. So what was the first sample? It said, so if we enter anything basically like 45, it only calculates 10%. But if we enter maybe 80%, okay, this one also works. What about 90%? This one gets us to 99. And if we do 95, so then it does that. So I guess anything above what, 94? So basically anything above 90. So anything above 90, it calculates both 10% and 15%. So what I'm thinking is happening here is that it first evaluates points if it's below 100, and then it does the calculation and prints the 10% bonus. But then because that now points is above 100, it also, so this condition evaluates to true. And then it prints, and then it calculates that bonus as well and prints out that the 15% bonus has been applied and then prints out the final points totaled. So I think if we just reverse the order of this, it should work that way. So say, for example, if we have points above 100, then it will apply the 1.15% bonus, the 15% bonus. But if it's anything below 100 points, then it'll only do this. So even if points, basically, if our points are above 100, it's not going to worry about doing this. Because the other way around was, even if our points were below 100, if we have a calculation that gets us above 100, it will then execute this block as well, which will then mean that the bonus is applied twice. We get both a 10% and a 50% bonus instead of just one or the other. So I think this should just be the answer. So if we run this and we say 95, yep, then it only runs once. But if we do 100, it also runs once. If we do like 20, it also runs once. So let's test this and see if we pass. And yeah, I think that was a little tricky in like the way that you have to think about it. But I think that was the way to do it. So this is their model solution. So they have a variable that tracks the amount of points that you have on your card. And then it asks if points are less than 100, then you do the 1.1 factor. And if points are over 100. So they didn't change anything. Oh, so they did the calculation outside. Right? So we do the factoring inside the conditional statement block, where they do it outside. So they set the factor as 1.1 and 1.15, and then they access the factor. So I guess hoisting isn't an issue in Python. So I'm learning something new here. Normally, in other languages, at least ones that I've worked with, any variable is declared inside like a conditional block like this, basically exists only here inside this block. So anywhere else, like down here, you wouldn't be able to have access to this factor, factor variable. So I guess hoisting isn't a thing in Python, but I'll have to do some research on that. That's actually very, very peculiar. But that's their solution, but I think mine is even a lot easier, right? Just check if we have over 100, equal to or above 100 points, then we just do this calculation, which will avoid doing this, and that's it. So yeah. Okay, here we have another exercise called What to Wear Tomorrow. And we're instructed to please write a program which asks for tomorrow's weather forecast and then suggests weather appropriate clothing. The suggestion should change if the temperature measured in degrees Celsius is over 20, 10, or 5 degrees, and also if there is rain on the radar. Some examples of expected behavior. What is the weather forecast for tomorrow? Temperature 21 degrees. Will it rain? No. And it just says wear jeans and a t-shirt. And if the temperature we provide is 11, and it doesn't rain, it says wear jeans and a t-shirt, and I recommend a jumper as well. And if the temperature is less than 10, doesn't rain, it says t-shirt, jumper, and take a jacket with you. Okay, so one thing we know for sure, at least that we can assume, is that if it rains, then we have to say that to take your umbrella. I think that's one of those things we could just do. Rain is equal to an input, and will it rain, which is just yes or no. Then we just say if rain equals yes, then we'll just say print don't forget your umbrella, like that. And I think we can assume that regardless of what temperature it is, as long as we're always going to be wearing jeans and a t-shirt, right? So I think we can just print wear jeans and a t-shirt as the baseline, and then everything else can be compounded underneath depending on what temperature it is. So we know that anything above 20, we need to recommend a jumper as well. So what we can say is if, so here we need to track the temperature. So we can say temperature, is this in Celsius or, yeah, Celsius. So temperature C is equal to integer input temperature. And then we're going to say if temperature C is less than or equal to 20, then we're going to recommend a jumper as well. So we're going to say print I recommend a jumper as well. And then if it's less than 10, if temperature C is less than or equal to 10, then we're going to print take a jacket with you. And then if it's less than 5, we do the other three. If temperature C is less than or equal to 5, then we're going to say print make it a warm coat, actually, and I think gloves are in order. I think gloves are in order. Okay, so let's run this. We'll do 21 and no to see if we just get this. Then we'll do 11 and no and see if we get these two, and do 7 and no and see if we get these three, and do 3. Okay, so the first one is just 21 and no. So it just says wear jeans and a t-shirt, which is what we got up here. Then it's 11 and no. 11 and no. It says wear jeans and t-shirt, and I recommend a jumper as well. Okay. Then we have 7 and no. 7, no. Wear jeans and t-shirt, recommend a jumper as well. Take a jacket with you. Yes. And then if we do 3 and yes, we should have all the above. 3 and yes. Wear jeans and a t-shirt. I recommend a jumper as well. Take a jacket with you. Make it a warm coat, actually. I think gloves are in order. And don't forget your umbrella. Fingers crossed. Let's test this. And yes, we do pass. Awesome. So let's view the model solution. So they didn't do less than or equal to, they just did less than 21. I recommend a jumper as well. And they did do this, so just by default, we wear jeans and a t-shirt. And if it's raining, don't forget your umbrella. And then just check below 21, below 11, and below 6. So they did one digit over, so it accounts for 20, but we did less than or equal to 20, so it also accounts. So it's inclusive of 20. So this will basically is saying if temperature is anything up to 20 degrees, because 21 is above 20, so it's going to include 20 here. And this is going to include 10, and this is going to include 5. But we did less than or equal to 5, less than or equal to 10, and less than or equal to 20, which is another way of doing this exact same thing. So they did exactly what we did. So awesome. Okay, and this we got another issue where it's already being evaluated. I don't know why, but we're told to solve a quadratic equation. It says in the Python math module, there is the function square root or squirt, SQRT, which calculates the square root of a number. You can use it like so. From math, import SQRT. So this we're introducing using modules and external packages and built-in packages. Again, not a fan of how some of this stuff is introduced kind of like in layman's, but I think this is supposed to go in tandem with the recorded lectures that they have in the home screen that I talked about, I think 2 videos ago. If you scroll down in the homepage of the course, you have these recorded lectures from last year. So I think some of the stuff is already introduced in these lectures, but we don't have access to those slides individually, so we can go over those slides and also do the exercises in tandem. So I'm kind of just reading the material and guiding you and guiding myself through these exercises. So I would assume that they would have introduced modules like square root in those slides in the recorded lectures that the university has posted. But let's continue. So it says you can use it like so. You, from math, import SQRT, and then print SQRT times 9. So this will do the square root of 9, which will print out 3.0. It says we'll return to the concept of a module and the import statement later. But for now, it is sufficient to understand that the line from math import SQRT allows us to use the square root function in our program. Please write a program for solving a quadratic equation of the form ax squared plus bx plus c. The program asks for values a, b, and c. So again, like this being a college level course, and it's from the University of Helsinki, and it's part of the computer science program, so you would understand that there's going to be some math involved. It's one of those things where people don't, when they talk about computer science degrees, there's a lot of math involved. You have to take college calculus, pre-calculus if you haven't taken it in high school. This is for US standards. So yeah, you have to take college calculus, pre-calc, calc 1, calc 2, and some other courses like discrete math and whatnot. So computer science degree is very, very math heavy. It's like, another way to think about it is taking a math degree with application in computers. I think that's also another way you can think about it, but yeah, it's a lot of math. So this is high school level math, but remembering formulas and whatnot, at least they provide it for us. It says it should then use the quadratic formula to solve the equation. The quadratic formula expressed with the Python square root function is as follows. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You can assume the equation will always have 2 real roots, so the above formula will always work. An example of expected behavior, so if we provide a as 1, b as 2, and c as negative 8, it says the roots are 2.0 and negative 4.0. So we can just print down here this final statement. The roots are, and then we're going to have a value for root 1 and a value for root 2. So we're going to have to track A, B, and C. I'm going to set these all equal to integers, cast it from the user inputted value of A, but we're just going to go individually here and change this to B and change this to C. So if you remember from math class, this here is called the discriminant. So we can just kind of break this whole formula down into little sections, particularly this area, because it's just kind of annoying, I think, to look at it this way. So we can just do discriminant is equal to b like that. Remember this operator from one of the previous sections, about the section about arithmetic operators, or operations, I should say. This double asterisk means exponents. So this is like writing b to the power of 2. But I don't think this will work in Python, so we have this double asterisk operator. So we're saying b squared minus 4 times a times c. Okay. And then what we can do is do root 1 is equal to negative b plus square root of, we're going to plug in the discriminant. In fact, I should probably wrap this in parentheses here and put that over 2 times a, and then do the same thing for root 2 as minus, right? Because this plus or minus basically means do this whole thing with a plus and then do this whole thing with just a minus, because we're getting 2 roots. Man, this is, wow. I also got to go brush up on math. I think this is right. And I'm trying to remember some of this terminology. But I think discriminant here is the right word. So let's run this and see what we do. So it said with 1, 2, and negative 8, the roots are 2.0 and negative 4.0. Let's just run 3, 3, 5. Okay, math domain error on line 12. Perhaps this? Math domain error. I think it's this negative b here. I think this will work, right? Like that. So 3, 5, 5. Still getting an error. Maybe I should do this. 3, 5, 5. Python math domain error. When a mathematical function from the built-in math module is provided with an input value that falls outside the function's defined mathematical domain. I think it's this. I guess it's not interpreting the negative b correctly. But I think this should be right. Because if we do it with 1, 2, and negative 8, it works. Let's test it. I know it's going to fail, but let's see. Nope, it passed. That's very weird. Let's see the solution. So they did the exact same thing I did. Yeah, this is exactly what I did. A, B, C, calculate the discriminant. Right, minus 4ac, negative b plus square root of discriminant, yep, over 2a. Wow, this is exactly what I did. So that's an interesting error. I'm going to take a second here and think about this, and then I'll continue the video. But we are done with all the exercises. So you can log off here and catch me in the next video. There's just a survey listed here, but that's the end of this section. This entire end of the first chapter is done here. I'm just going to do the survey off screen. But I'm going to pause the recording here for a second and see what's causing this error. And then I'm going to come back and talk about it a little bit. I think we still have a little bit of time to solve this. But I think that's an interesting error. I don't know why it works with the values that they provided, but not with any other value that I provide. Okay, I know why. Again, so this is just some math stuff that you gotta remember. So not every equation is going to have a solution, that's basically what's happening here. So when I input 355, it basically means that this, what is it, 3, when A is 3, B is 5, and C is 5, so we do 3x squared plus 5x plus 5, that equation has no real roots, so it's giving me this error. But 1, 2, and negative 8 do produce real roots. So it's not that my code is wrong, but it's because basically the values provided don't result in a real root. And so I guess their tests don't test for that in this equation, which is fine because, in this exercise, which is fine because, we're just, it's not really important, but in the real world scenario, if we were to evaluate this by hand, we will see that 355 produced no real roots. So you could add like a conditional if, the discriminant equals what, 0 or something like that, then, just return there are no roots. But this works. So our work here works, and it's virtually the same solution that the instructors recommended. So you can extract the discriminant from here, or you can just do this, right? Just plug it back in like that and get rid of this, and it should still work. Yep. But, the other way is just a little bit easier to read, but that's the solution. So I'm going to go and spend some time going through all my solutions for all the exercises that we did in part 1. I'm going to upload them straight to GitHub. And if you want, you can go to the GitHub and look at my solutions. I'm going to put them all in one document. You can go look at the solutions, compare it to what you got, as well as comparing it to what the instructors produce in their model solutions. They should be pretty close. But other than that, I hope you guys enjoyed this first chapter. I will continue with parts 2 all the way down to 7 for the introductory part of this course. Thank you so much for watching.